Do you want to learn how to design such a computer application that can receive multiple sensor values in one message and then split that message and display each sensor value in its own box? Then watch this tutorial from start to the very end. Hi guys, my name is Fahad and welcome to Electronic Clinic. If this is your first time here and you want to learn Arduino programming, PLC ladder logic programming, SCADA application designing, SolidWorks, Visual Basic application designing and programming for microcontrollers to send and receive data, Android, security systems, robotics, image processing and much more, start now by subscribing and clicking the bell icon so that you never miss anything. Welcome back my friends. First of all, let me tell you about the importance of this project and where you can use such monitoring application and what's the advantage of splitting the sensors data. As you can see on the screen, such type of applications are used in industries for monitoring different sensors all at the same time. This application can be used for security purposes, weather stations and so on. In simple words, we can say that this application has infinite uses. You can use this application for any purpose. Now the first question that comes in our mind is that why we need to split the sensors data. What we are receiving all the sensors values in one message. Why we are splitting the sensor values when we are receiving all the sensor values in a single message? Which is such an important question. Now the first answer is that reading this information is very difficult as compared to this one. We can easily read the values, the status, whether it's high, low, or the door is open and closed, and over here reading all the information is very difficult. And the second answer can be like, for example, you want to make a feedback system for the temperature and for the motor speed. Like for example, when the temperature exceeds 450 centigrade and you want the computer application to send a command to the Arduino microcontroller to turn off that motor, then how you will do that? And for example, when the RPM exceeds 3000 and you want the microcontroller to turn off that motor, then what will you do? How you will send a feedback signal from the computer application to the microcontroller? So for that you will have to access these values, you will have to split these values, you have to store these values in some kind of variables. So for this purpose you will need to split the sensor values, so which will really help you. So by splitting the sensor values like these, then you can individually apply conditions on each sensor value. Then you can do whatever you want. So you can save these sensor values into a database, or you can send these values in a message, or whatever you want to do with this you can. So today's episode is about how we send a complete message from Arduino to the computer application, and then we use computer application to split the sensor data. And so let's get started. So my friends, this is the basic circuit diagram which is designed in Eagle 6.3.0 professional version. If you want to learn how to design schematics and how to make PCBs, you can watch my tutorials on schematic designings and PCB designing. Now in this episode we are not going to use so many sensors. Actually we will be using only 2 sensors. Whether you are using 2 sensors or whether you are using 50 sensors, the technique is the same. So is episode about the multiple sensors. So as you can see that we are using more than one sensor, we have 2 sensors, and we will split the values. So let's start with the LDR circuit. This is a very basic circuit. The LDR is connected in series with a 10k resistor, and on the LDR 1 pin the 5 volt is connected, and Over here you can see a ground is connected, so which makes a voltage divider, and from the middle we have taken a wire, and this wire will be connected with pin A1 of the Arduino. So when the light will be changing, we will get different voltages, and those voltages will be converted into digital values by the ADC, which is the analog digital converter, and those different values will be sent a message to the computer screen. And now this is a variable resistor, so we'll be using two sensors. The one is the LDR and the other one is the variable resistor. So by changing the variable resistor knob, we can send different values. So as the variable resistor has 3 pins, so the rightmost pin is connected with 5V, the leftmost pin is connected with the ground, and the middle one is connected with the analog pin A2. So this is a very basic circuit diagram. We're using two sensors, and we will first of all read these two sensors, then we will make a message, and then we will send that one message to the computer application, and then the computer application will split the sensor values and display the LGR value in one box and the variable resistor value in another box. And now let's start the circuit interfacing. Okay, so now my friends, as you can see, the components are interfaced. This is the LDR and a resistor which are connected in series. Now the white wire is connected with the 5V, the black wire is connected with the ground, and the gray wire is connected with a 1 pin of the Arduino. And similarly for this variable resistor, the red wire is connected with pin number 2 because I'm supplying 5V from here, and the middle wire is connected with A2 of the Arduino Uno, and the leftmost wire is connected with the ground of the Arduino. And now let's start the programming. So my friends, this is the controller program, and let's start with the string text for SMS. So we are defining a variable of the type string, as we will be sending a message to the computer application. So for that we will be needing this. And integer LDR equals to A1. So as I explained in the circuit diagram, that the LDR will be connected with a 1 pin of the Arduino, and similarly the variable resistor will be connected with a 2 pin of the Arduino. And now over here I will be needing 2 more variables of the type integer. So integer L data equals to 0, this will be used for the LGR value, and integer V data equals to 0, and this will be used for storing the variable resistor value. Every Mega and Arduino program has at least 2 functions, which are the white setup and the white loop. White means that this function is not returning any value, and the empty parentheses means that this function is not taking any argument as the input. So as we will doing serial communication between computer and the Arduino, so for that we will activate the serial communication, and we will define the baud rate. So serial dot begin, and that is 9600. So we will be doing communication with the computer at a baud rate of 9600, which is bits per second, and there is a semicolon which is used as a terminator and tells the compiler that the instruction is completed. Then pin mode function, and it takes 2 arguments as the input. One is the pin name and the status, whether we are going to use this as an input or as the output. So as LTR as an input device, so that's why it's input, and we're also using the variable resistor as an input device, so that's why it's input. And pin mode to output. So as I explained this, that I will be giving 5V to the variable resistor with the help of the pin 2 of the Arduino, so that's why I will keep it high, so digital write to high. This will give 5V on 1 pin of the variable resistor. And then there starts a while loop function which runs infinite time, while the while setup function runs only 1 time when we turn on the Arduino. L data equals to analog read LGR. We read the LDR value and store that in L data, and then we read the V resistor using the analog read function, and then store that value into V data. Then after that we create a message. So how we create that message? Text for SMS equals to text for SMS plus the L data and plus the comma. Actually, this will be used as a delimiter, and with the help of this we will separate these two values. And then the v data, so the value which is stored in this variable will be added over here, and the value which is stored in this variable will be added over here, and then there's comma. Serial.println text for SMS, then we'll send this message to the computer application, and then after that we just clear the text for SMS variable, and then there's a delay of 1000. So that's the complete program for the controller, and now we'll start the application designing and programming. So open Visual Basic, which is Microsoft Visual Basic 2010, and click on the new project. Make sure that you select the Windows Forms application and click OK. Okay, so now we will be needing a label, so double click, add a label, and we will be needing a text box. Click here and select multi-line. Okay, and now click again. Now Control C, copy, and Control V, paste. We paste again. Let's use this label over here. And name this as the LDR, and copy and paste, and this is variable. Okay, and we will need another label, which I will tell you in a couple of minutes why I need this one. Okay, so as we will do serial communication, so for this we also need a serial port. So double click over here. So as you can see over here, it's added, and now double click on the timer. So we will also be needing a timer, as we will be reading the serial port every 1 second, after every 1 second. So change this to 1000 milliseconds, which is equal to 1 second. So what it will do, it will clear this text box after every 1 second, and will perform some conditions, so which I will tell you. So now the basic form design is completed. The two sensors, the boxes for the two sensors are here. So a message from the Arduino we will send over here in this text box, and then we will use the programming to split the sensors data, and then display the LGR value in this box and the variable register value in this box. And now we will start the programming. So my friends, double click over here and enter, and start by typing imports system.io and imports system.io.ports, which will be used for serial communication, defining the input and output port. So, and we will also need one variable, and that is dim value1 is integer. Okay, now with the form1 load, so as we're using serial port 1, its name is serial port 1, and the baud rate is 9600. And as I have already connected the Arduino with the laptop. So first of all, let's confirm the port number, and as you can see, it's COM5. Let's upload this program. Okay, the program is uploaded, and okay, and now double click and start coding over here. So start with serial port 1 dot close. So close the port. If it's already open, so it will close the port, and then serial port 1 dot port name equals to COM5, as it's installed on COM5, and as the baud rate we have used 9600, so serial port 1 dot baud rate equals to 9600, and serial port 1 dot data bits equals to 8, and serial port 1 dot parity equals to parity dot none. Serial port 1 dot stop bits equals to stop bits dot 1, and serial port 1 dot handshake equals to handshake dot not. We don't need a handshake. And then serial port 1 dot encoding, which is equal to system dot text dot encoding dot default. And then finally we will open the serial port, so serial port 1 dot open. Okay, let's save this. Okay, now to save some time, I already did the programming and checked in is working fine. So now next step is that, so far we just completed this portion that this will be used for accessing the serial port, and now we will start programming for the timer. So come here and double click on the timer. So when you double click on the timer, then you will start coding from here. So first of all, you will have to define a variable dim s as a string. So s is of type string, and then s is equal to text box 1 dot text and plus the delimiters. Okay, and then this is just an empty message. Okay, so anything which will be received over here, it will be saved in s. Okay, and then some string is string. So some string is equal to s dot split new character, and for example, if you are using colon, then you can replace this with the colon or any other character, but as I'm using the comma, so I will use comma over here. So this is a function which is used for splitting the string. So text box 2 dot text equal to some string 0. Actually it will be converted into an array, so I'm now accessing the values. So it's 0 location, and value 1, which I defined over here, that value 1 as integer. So value 1 is equal to convert dot to decimal text box 2 dot text. So the value which is stored in here will be converted into the decimal value. on which then we can apply some conditions, which I will tell you how to apply. So I have just converted this one value into a decimal, and then text box 3.text equal to some string 1, and text 4.text equal to some string 2, and so on. So for example, if you're using 10 sensors, then you will use 10, 11. So, and then text box 1.text equals to empty. So this text box will be empty after every 1 second. Okay. And then if value greater than 600, and that is the value of the LDR, if that is greater than 600, then label 3.text equal to full bright, else label 3.text equals to the medium light, and so. Okay, so if I run this code, okay, first of all let me tell you about this. So you start by typing the private sub data received. It's a function actually. By value sender is object, and then comma, by value e a serial data received event args, the parentheses closed handle serial port 1 dot data received, and try and catch. So this is for the error. If in case there's any error, we can find out about that error in this way. So try my data is string is equal to empty, which is just an empty, and my data equals to serial port dot read existing. So anything which is available on the serial port, read that and save that into my data. So if text box 1 dot invoke required, then what to do? Text box 1, actually this is text box 1. So then the if text box 1 dot invoke required, then text box 1 dot invoke direct cast sub, which is a function, and text box 1 dot text end equals my data and the method invoker, else text box 1 dot text plus equals my data and if. So gauge ex as exception message box dot show ex dot message, and try, and then the function is completed, and this is the end class for here. So now the programming is completed. It's a very simple program, and now we can play it. So well, the Arduino unit is already connected with the laptop, so let's play this. Okay, so as you can see, we are receiving that message over here, and now with the help of that program, we are now splitting these values into 331 and 532. So when I rotate, let me rotate the knob on the variable register. So as you can see, the variable register value is now increasing, and when I rotate it back, so the value is decreasing. And over here the light in my room is 324 is fluctuating, so let me some shadow. So when I put some shadow on the LDR sensor, you can see the value is fluctuating. So as you can see, so this is a way that how we can split. And over here this is the medium light, because the value is less than. Over here what I used, the condition was if the value is greater than 600. So I can change this value. For example, if this value is greater than for example 300. So if the value is greater than 300, then full bright, you can see over here. So let me just place my hand on the sensor, and now you can see the medium light. And when I remove my hand, and now you can see it's a full bright. So this way now we can individually apply conditions on these values. So that's why I recommend that whenever you send sensor values in a message, then split those messages and store. Then you can save those values and in other variables and apply conditions. So the way I showed you this. So that is, I hope you liked today's episode. If you have any questions, feel free to comment, and if you require help, if you need help for any project, tell me. I will make a tutorial on that. So if you have any suggestion, let me know. I will really appreciate this, and Please don't forget to subscribe and keep visiting Electronic Clinic. See you next time in another episode, and bye bye.